Hey guys, welcome. It is a triangle proof video and it's coming at you. Alright, here we go. First part of every proof is we think and analyze before we begin. So let's go ahead and mark some important information. LT is congruent to TR, so here's LT is congruent to TR. Again, we're trying to prove these two triangles are congruent, LIT and TER triangle. And to do that, we're going to use one of our special methods. We have this little sheet to help us. So those are our different methods that we can use. Let's see what else we got. So I took care of that given piece, so we're good there. ILT, so ILT, this angle right here, is congruent to ETR. So there we go, just like that. And then IT right here is, oh, my computer's loading. Okay, and IT right here is parallel to ER. Okay, so let's see if we can figure something out here. Well, that's all the given information. From this information, is there anything I can pull out of it? Well, I have a side and I have an angle. So I have an angle and I have a side. So according to my list of things, I'm probably either going to use angle, angle, side, side, angle, side, or angle, side, angle. Okay, so I need to either show another side or I need to show another angle. Well, considering these two lines are parallel, that means LR is our transversal, and that means this angle right here should be congruent to this angle because these are actually corresponding angles. Kind of hard to tell, but those would be corresponding angles. So we should be able to prove this by angle, side, angle. And let's see if we can go ahead and complete this proof. Again, every proof our main focus is pick one of these and attack. Okay, LTR is congruent to TR, that was given. Whenever I do a proof, again, I like to show that I proved something. So there we go, we have my side. ILT is congruent to ETR, given. That shows an angle. Parallel lines, given. This whole thing's given, basically. I'm okay. LTI, that's exactly what we said here. ERT, that's what we said here. They're congruent because they are corresponding angles. Okay, so corresponding angles theorem. I know the order in which I prove them isn't the same way they look in the picture, so it doesn't matter how I show it here, it's what it is in the picture. So are these congruent? Yes, by what? Angle, side, angle. Okay, let's take a look at the next one. Make sure you're writing everything down in this picture. Okay, here's our next one. Again, we're going to read first and mark, and then we're going to move. So write down the picture and so we can chat. C is the midpoint of BD, so C is the midpoint of BD. So the first thing I should note is that if that's true, these are going to be congruent. Okay, it's going to bisect those. All right. Next, what do we know? So AB is perpendicular to BD. So this means there's a 90-degree right here, and BD is perpendicular to D. So that means there's a 90-degree right there. Okay, so we have an angle again and a side, and we should all notice these are vertical angles right here. And so we are going to get, again, angle, side, angle. We figured it out. All we have to do is basically explain that. Given, yeah. Okay, so we started out with the given. BC is congruent to CD. I said that, and that was because the definition of, and what word they use? Midpoint. Okay, so the midpoint tells me that I'm going to break these two up, okay? So the definition of midpoint, BCA, so this angle here, and ECD, those are congruent because those are vertical angles. And what if I forgot to do? I forgot to label each piece. So I proved a side right here. I proved an angle right here. ABC and EDC are right angles. That's a definition. We can use definition of perpendicular if we want here, because we did state that they were perpendicular. That would make the most sense. Then we can say they're congruent. Now we have to throw in our next A, and that's because what? Right angles are congruent. Okay, so we have a theorem for that. If you can't remember the name, you can literally just write right, if you can spell the word like I can, right angles are, I don't know why my pen's get all messed up, are congruent. Okay, and then last but not least, we know these two triangles are congruent. Why? We stated up at the top, angle, side, angle. Okay, so it's kind of like just trying to identify, are these triangles congruent, and then we just make sure that we label each piece. That's it. And then at the end we say, here it is, this is why. So it's a very structural proof. Let's do one more. Okay, this will be our last one. Again, draw this out. We first want to write down what we got, BC, so let's get our color red. BC is congruent to DA, so I have a side. AC bisects BCD, so that means this angle here and this angle here are going to be congruent. Okay. So we have a side and we have an angle. AC is bisecting BCD. And then we share this side right here, correct? Okay. I write that correctly. Yeah. Okay. So what can we do here? So I see in this picture up here we have side, angle, what? Side, right? BC, angle, side. And then over here we have side, angle, side. So that's not going to work. Okay, so is this one provable? I think they messed up on their proof. Let me double check it. Okay, I looked at this very carefully, and they messed up on this proof, which I think is a good learning moment. Okay, so we can always learn from mistakes. Not that I made it, but that they made the mistake on this proof. So we do see in this top triangle we have side, angle, side, which would be perfect. That's one of our 5. But down here they have side, side, angle. Okay, so if we recall from our false shortcuts right here, we cannot have side, side, angle. So this would actually not work. You couldn't prove it. So they messed up. What they really should have done, instead of saying it's equal to DA, they really should have said to CD. That would make this angle included. Okay, but they made an error, so we can't do it, which is very rare for that to happen. All right, so I guess get out of doing an extra one. Ciao.